We've been discussing solutions and their properties, and in doing so, we can describe solutions in a variety of ways. So here we're going to talk about differences between saturated, unsaturated, and supersaturated solutions. So as part of that conversation, we want to talk about equilibrium. Many processes are going to achieve equilibrium. Now, this occurs whenever we have a process that's reversible. And the equilibrium itself occurs when the rate of a forward process becomes equal to the rate of the reverse process. And we're going to get into equilibrium in more detail in later videos. Now, when it comes to a solution, a solute can dissolve, so we can consider that our forward process, but it can also precipitate back out. So that would be our reverse process. So if we look at our image here, we've got sodium chloride. So when we initially place sodium chloride into water, the sodium and chloride ions begin to dissolve in the water. So the intermolecular forces take charge, they surround those ions, they break those ionic bonds, and we start to get the ions surrounded by water in solution. Now, as the solution becomes more concentrated, some of the sodium and chloride ions can begin to recrystallize as solid sodium chloride. So that's where we get our two processes. Sodium chloride is dissolving, but it can also precipitate back out. When the rate of that dissolution equals the rate of the recrystallization, we get what we call a dynamic equilibrium. And so both are occurring at the same rate, and we see no changes. So we don't get additional material dissolved, we don't get additional material precipitated back out. So when the two rates become equal, a solution will have reached a point at which the maximum amount of solute is dissolved. Like I said, there won't be any more changes. And when that's the case, we describe that as a saturated solution. There are cases in which we actually want to prepare a saturated solution. So to ensure that that solution remains saturated, it's got to be in equilibrium with undissolved material. So when we make a saturated solution, we add as much sodium chloride, for example, as will dissolve, and then we add more so that there's solid at the bottom that remains in equilibrium with our dissolved substance. So that was one situation where we have a saturated solution, no more solute will dissolve. Now, an unsaturated solution will be one in which we have less than the maximum amount of solute dissolved. So there's room to continue to dissolve more. And then finally, a supersaturated solution is one that has more than the maximum amount of solute dissolved. These solutions tend to be unstable, and precipitation can be triggered by seeding or agitation. So looking at some of our problems, when observing a saturated sodium chloride solution, we see a layer of solid on the bottom of the container. We're asked, why is the solution made that way? So we just talked about that. That is to ensure that equilibrium. And that equilibrium ensures that the maximum amount of solute remains dissolved. Now looking at our next problem, we have a solution of glucose. Upon observing the container, you see there is no visible solid. You add 0.5 grams more of glucose to the solution, and you mix it, and you find that that glucose dissolved. So was that solution saturated, unsaturated, or supersaturated? And so if we think about our two solution types, if it was saturated, it would not have dissolved. That glucose would have fallen to the bottom because we would have already had our maximum amount of solute dissolved. If it were supersaturated and we added that glucose, we would actually have possibly seen more solid dissolve because that would be that seeding. We add some crystals of glucose and they precipitate out. So this solution is going to be unsaturated. The fact that we were able to add more solute and it dissolved meant that there was still room. It didn't have the maximum amount yet. And then our final problem, we have a solution of vanillin. We take our glass stirring rod and we scrape the inside of the flask, and suddenly we see white solid form rapidly. What kind of solution do we have? So we had something that looked like we had everything dissolved. We scraped it, which is an agitation, and suddenly we get precipitation. That is a super saturated solution. So we bring up this example of vanillin because if you took first semester chemistry here, you would have done a lab working with vanillin. And in heating or in doing that lab, if you had heated your sample and then you tried to cool it too rapidly, then your particles get trapped in that solution and it becomes super saturated. So it's necessary to shake or scrape the inside in order to get precipitation out, which was the goal of that experiment.